This week's Cloud Customer Success Customer Office Hours. This is for the EMEA region. As per normal, you can ask us any questions you like and we can have a good old discussion about it. Anything related to VMware Cloud on AWS or anything else that takes your fancy that's related. We have a Q&A box within the Zoom session if that's how you've joined, and there's also a chat stream within Twitch itself. So all those out there watching via Twitch, good morning and welcome. If you're catching this on YouTube, this is the 10th of April. And we're good to go. So this morning on the panel with myself, we have Prasanna and Rick, both colleagues in the customer success team. And we also have Jeffrey Moore, who is a fellow VMware colleague as well.
Hello, everyone.
Good morning. So this morning, what we're going to be doing is taking a look at a couple of things that have cropped up, and Prasanna is going to be talking to us about the load balancing from AWS, and then presenting that to your SDDC in VMC. So without further ado, what I'd like to do is get the Zoom session up, and then get Prasanna to present his desktop. And then we can go through that if you're comfortable with doing it. Brilliant. There we go.
Sure. Yeah, thanks, Phil. You can see my screen, right?
We can indeed, yeah.
Okay, cool. So yeah, I think in today's session, we can talk about deploying the load balancer in the AWS VPC and add targets from the SDDC side. But I guess the real intention behind that scenario is to talk about the cross ENI and what are the various aspects that are involved and what are the different configurations we have to complete in order to achieve this connection between the VMC SDDC and the native services in AWS. So we are just taking load balancer as an example in today's session, but yeah, it's also applicable to other native AWS services. So yeah, so before we jump into the topic, just a quick brief about the cross ENI and how it works. And we are not touching upon like how to create the SDDC and how to create the linking. So those topics are covered sufficiently in the previous sessions. So we'll jump on directly into the cross ENI and the load balancing stuff. So just to touch upon what cross ENIs are. So basically, in the right-hand side, we have the SDDC, and I'm referring to the Dustin's onboarding guide, which has awesome stuff here. So I'm just using this diagram to explain like how this cross ENI works. So in the SDDC side, in the right-hand side, we have our ESX host and the entire SDDC stack spun up. And you can see that we have two segments, basically. The management components are on the management network, and all the workloads created by what customers will reside on the compute networks, and both are protected by the NSX edge. So this SDDC is basically connected to the VPC or the customer VPC, which is on the customer-owned AWS account. So it's important to understand that this AWS account is totally separate and distinct from the SDDC. And this section in the left-hand side is completely owned by customer. So we are just providing the option to the customer to choose whichever account they want and whatever VPC they choose to be linked with the SDDC they are going to create under VMware Cloud on AWS. So this provides an option to provide this direct connectivity between the workloads in the SDDC and the native AWS services. So the main advantage here is this traffic that goes over this connection is completely free, and also it provides the low latency and high bandwidth connectivity between these two segments. So most customers take advantage of this. So one of the use case I could think of, even customers who don't necessarily use native AWS services, they also use this connection, say for example, to back up their workloads in the SDDC to the VPC or the AWS storage. So that's one use case where even customers who don't necessarily are a big AWS shop, so they also use this connection pretty frequently. So I'll just take a path there to see if there are any questions. Okay. So yeah, so just to jump in one level deep, just to see like how this ENIs look like, I will jump on to the AWS console. And before doing that, let me quickly show the setup in the SDDC side. So those who are familiar with, this is our VMC portal where we can create and manage the SDDCs. And so in our org, or in this test org, we have 4 SDDCs, and I'll pick this one and get into the networking and security. So this is after the fact. So we have already deployed the SDDC. It runs for about 2 hours to create the SDDC, and so we can get into the networking tab and get into the connected VPC to check which VPC we are connected to and which subnet or which AZ we have linked the SDDC with.
Prasanna, it's just briefly, it's worth pointing out to people watching this either live or on the recording that you may see some features here in our lab that may not be available to you. That's obviously because we use this for testing purposes as well. So we may have some pre-release features visible. So don't be worried if you see something that looks slightly different from yours. Sorry, carry on.
Oh yeah, that's a good point. Thanks. So yeah, so at the time of SDDC creation, so we have selected this VPC and this AZ and this subnet to link with, and we can also see information like which ENI is currently active. So we will see how this looks like in the AWS side. Quickly jump onto the AWS and get into the EC2 view so that I can see the network interfaces. And if I scroll down and under network interfaces, I can see there are lots of ENIs or elastic network interfaces created. And there are a bunch of ENIs which are with the description VMware VMC interface. So these are the interfaces that are used by the ESX host on the VMC side or the SDDC side to establish this linking. Now, for those who are not familiar with AWS, we need a network interface attached to any workloads or any instances that needs to communicate to the outside world within the VPC or outside of VPC. So this ENI is required to achieve that connectivity. Since the SDDCs are not directly residing within the VPC, so they are basically on the SDDC side. If I go back to the diagram here, so you can see that the ESX hosts are on the SDDC side and not directly residing within the VPC subnet. So we are basically creating this ENIs and attaching this ENI to the ESX host on the SDDC side. So that is a special case because if you look at these first 3 or 4 ENIs. So they are directly attached to the objects within the VPC, but that's not the case with these ENIs. So that is why we call them as cross ENI. At least I call it as cross ENI. Because these ENIs are not directly attached to the instances within the VPC, but they are used by the ESX host on the SDDC side.
And if you could just explain why we have so many listed there as VMware VMC interface do not use, but actually only one is in use, that'd be really useful.
Yeah. So at the time of SDDC creation, we just instantiate about 16 ENIs by default. And so what this means is each host in a cluster is assigned an ENI interface within the VPC. And you can see that this IP is grabbed from the VPC subnet. So even though all the hosts are given an ENI at the time of SDDC creation, only one ENI is active at any time. So the reason for that is all the north-south connectivity to the SDDC is handled by the NSX Edge as shown here. So it can be either internet access or direct connect, or similarly, the VPC connection is also handled through the NSX Edge, and whichever host that holds this NSX Edge appliance, so that ENI is going to be active at any point of time. And we can see which ENI is active currently. And we can identify that with this green symbol, and as well as there will be a secondary IP for the active ENI that is in use.
So if the edge
And,
device vMotion to another host, a different one of these interfaces would light up. Is that correct?
Exactly. So it will just, the secondary IP will just get attached to the other ENI, or whichever host the edge moves to. So this will be moved to that, and it becomes in use.
Fantastic. Sorry, carry on.
And I think we can also check the ENI number here. So it ends with 748, just to quickly verify. Yeah. So we can see like which interface is currently active. So yeah, so this basically provides access to the workloads in the SDDC directly to the AWS native services. So that's a brief about cross ENI, and I guess we can move on to today's scenario we have planned for. So the plan is basically to deploy a load balancer in the AWS side, but host the web servers in the SDDC. So I'll use these two CentOS servers.
And Prasanna, why would we deploy the load balancer in AWS native rather than something within VMC itself?
Oh yeah, so that's a good question. So you could see that we have many network functions here that are made available for the customers. So all these functionalities are managed by NSX in the backend. So this is just the front-end portal through which customers can make use of these functionalities. So this is more of a simplified view, we can say, so that they don't have to log into different portals and modify this configuration. So we can see that we currently have many functionalities like IPsec VPN, NAT. Of course, we have firewall to protect access, and a few other features. But as of today, we don't have load balancing made available. And so it is on the roadmap. It's going to be available in the upcoming releases. But since we currently don't have load balancing available natively, customers have a couple of options to load balance their workloads within this SDDC. So either they can deploy a virtual appliance within the SDDC and load balance their web servers, or they can go for using AWS native load balancing options from their VPC. And this cross-linking is useful in that specific scenario where this traffic between these two segments are free. So they can take advantage of this connectivity and use the load balancing options within the AWS. So there are both pros and cons with both these approaches. So I wouldn't say cons, but it depends on like the specific customer situation. Say for example, if they don't want to deal with the contracts for the virtual appliance and they don't want to go through the cycle, they can just go for deploying the load balancer in the AWS side and just get started. Or on the other hand, if they already have some kind of licenses for the virtual load balancers, they can just go ahead and deploy the load balancers. So it really depends on the customer situation.
And would there be any difference in charging for data, for example, if they were deploying within the SDDC as opposed to deploying within AWS native?
Yeah, so there is a slight caveat or consideration when we deploy the load balancer in the SDDC. So we only support one armed mode as of today, meaning the load balancer also resides in the same segment as the web servers. So we cannot configure the load balancer as the default gateway for the servers and tunnel the traffic through the load balancer. So yeah, so the key point to remember here is we support the load balancing in one arm mode scenario. It cannot have like two interfaces and the traffic coming in via one interface and getting out via the second interface.
Okay.
So that's something to keep in mind when we deploy in the SDDC.
Yeah, good to know.
Cool. So yeah, I guess we can proceed with the load balancer deployment. And just to quickly show the VPC setup currently. And remember, this is the customer-owned VPC, and this is completely owned by the customer as against the SDDC side. So this is managed by VMware, and customer has controls to multiple functions. So the reason for highlighting that is any service we utilize in this AWS account is charged under the customer's AWS account, and any consumption here within the SDDC, meaning the number of hosts primarily. So that is going to be charged under VMware billing. So that's something to keep in mind. And this is the VPC we are currently using to create that linking with the SDDC. And so let's look under the subnets. Yeah. So these are the subnets that are part of that VPC. And I believe we are using the 2A availability zone. Yeah. So we have linked with this specific subnet in this AZ. So another point to remember is whichever subnet we are linking at the time of SDDC creation. So the SDDC is also going to be created in the same AZ, meaning all the traffic within that specific AZ will be free of charge. So just to elaborate on that, going back to the diagram here, you can see that the cross ENIs are connected or created in this specific subnet and specific AZ. Even though it is created in a specific AZ, the connectivity is still available for the entire VPC, meaning we can still access the EC2 instances that might be available in AZ1 or AZ2 for that fact. But the traffic charge is only free between the same AZ and any traffic that traverses across AZ is charged. And that is the case within the VPC also. So any traffic you are utilizing within the AZ is free, and if you go across AZ, it is always charged. It's not as costly as the internet egress, but it's still charged. Okay. So this is basically the setup, and I will also quickly show the route tables for that specific VPC. And you can see that the default route is pointing towards the internet gateway so that we can access the load balancer and have internet access. So this is interesting. You can see a bunch of route table entries here. And let me jump back to the SDDC and look at the network segments that are available within the VPC. So we could see that there are a bunch of routed segments that are created, and there are a few extended segments. Whenever we create a routed segment within the SDDC, so there is going to be a route table entry that is getting added automatically by the automation. So customers don't have to do it every time. So it's done automatically, and these SDDC segments are pointed towards the cross ENI, meaning for any destination that is available within this segment, so that traffic is going to be routed towards the ENI, and it's going to take care of routing towards the HDDC. So that's basically the idea behind adding these static routes within the routing table. So one key point to remember with the routing table is, so the automation as of today only uses the default routing table, which is attached to the VPC. So in case you are using a custom routing table, this automation will not do this updation. So this is also important because potentially a customer can create a custom routing table and configure these manually, but this becomes challenging when the NSX edge moves over to a different ESX host. And we know that whenever the edge moves over to a different host, the ENI used will also change. And this ENI will get automatically updated if it is in the default routing table, but this will not get updated if it is a custom routing table. So as of today, the advice is to use the default routing table for this cross ENI connection. Okay. So I will touch upon the security aspect of this connection. So we basically have check posts. In fact, there is a diagram that shows that literally. So we have check posts on the both side of the cross ENI, one on the SDDC side and the other on the AWS side. So we'll talk about this once we deploy the application load balancer. So I'll quickly jump on to the EC2 view and go to the load balancers. And so I can see that there are already a couple of load balancers, but let me create a new one for this session. And of course, we have different load balancers. So for this demonstration, we can go for application load balancer, which basically does the load balancing at layer 7 against network load balancer, which is more layer 4. So it depends on the use case of the customer. So for this demonstration, let's go for ALB. So I'll just go for the default options. So the web servers I'm currently hosting in the SDDC. So they are basically simple web pages servicing on port 80. But typically customers go for HTTPS. And whenever we choose HTTPS, we will have to configure certificates in the next step. So I don't have one, so I'll just go for HTTP. And which VPC we are going to place this load balancer on. So let's choose the linked VPC, and we know that this is the VPC we have linked with the SDDC, and the specific subnet which is currently linked with the SDDC. So for the application load balancer, it is recommended to choose at least 2 subnets for high availability purposes. So let me choose second AG as well. And we know that the connectivity is provided for the entire VPC. So we will still have connectivity to both subnets or both AZs over that cross ENI. So we are good connectivity wise.
But does that mean though that we've deployed everything in the SDDC that's linked to subnet 2A? So if then 2A drops, obviously we've got nothing anyway, but would there be a charge then from 2B, you know, the cross networking charge?
Yeah, so in case 2A is not available, yes, so the traffic is going to be coming from 2B. And since the SDDC is in 2A, it's going to incur cross AZ charges.
Cool.
So it's just a warning that I'm not using secure protocol. So let me go ahead and choose the default security group for now, and I'll touch upon like what are the entries that are available in the default security group. So the targets is where we are actually adding the endpoints or the web servers that are serviced by this load balancer. So the first step is we just configure the listener for the incoming traffic from the internet. It doesn't have to be internet, but in this case, it's from internet. And the target is where we are actually adding these web servers from the SDDC. So let me grab this IP. And since these are not instances residing in VPC, so these are IPs reachable over the cross ENI, I'm going to choose the IP option here, and I'll leave the HTTP and choose other private IP address here. So the first option is just showing the VPC. So let me go for other private IP. Add to list. So other one is .20. So I'm basically load balancing between these 2 web servers. Let's just review and click on create. So this is the load balancer we just created, and it is listening on port 80 and it is forwarding to SDDC targets. So let me jump to target groups and SDDC targets. So I can see that these are the web servers and the status is still initializing. So while this is getting provisioned, I think this might be a good time to talk about the security check posts on both sides.
Just before you do that,
so,
mate, how long roughly does that then take to fully deploy and be available normally?
Yeah, it takes about like 30 seconds.
So pretty rapid then. Yeah, that's cool.
Yeah, it's pretty fast. So that's why I mentioned. So that might be one of the considerations for customers choosing between a load balancer appliance within the SDDC and native load balancing. so they can just get started within minutes if they go for this. So yeah, I'll go to the security groups. Or first, let me show the diagram here. So let's assume this road has crossed ENA and VPC is on the other side and the SDDC is towards the bottom. So the first checkpost is the NSX Firewall, and this can be modified from within the gateway firewall section of the SDDC, and we can add firewall rules for different access. So it can be from the on-prem to the SDDC or to the internet. So let me quickly show an example. Or just edit one of the existing one. Yeah, I don't see a firewall rule for VPC in and out. So let us create firewall rules for this specific connection between the SDDC and VPC. So let me name this as VPC in, meaning I'm allowing traffic from the VPC into the SDDC. So the source should be VPC. I'm sorry. So a key point to remember is we have two segments here, the management and compute. Since my web servers are residing in the compute section, so let me quickly jump to the compute side.
That's a well-planned, obvious mistake there. Well done. Good highlighting.
Yeah. So yeah, I already have created the VPC in and out, but let me quickly show how this looks like. So I'm basically allowing traffic from the connected VPC subnets. Let's quickly have a look. So you can see that this is the subnet range for the entire VPC. And I'm basically allowing access to specific subnet which are hosting these web servers 10.7.2.66. And right now I have allowed any, but I can potentially restrict this to port 80. So let me do that. So I can also search for a specific service. Hello. And so this is interesting here. So I can apply this rule specifically on a VPC interface. So we have multiple interfaces in the NSX. So there is an internet interface which takes care of the public traffic, and there is also a separate interface for direct connect and VPN. So what I'm doing here is I'm restricting this rule to only VPC interface so that I don't accidentally allow traffic over the internet. So we can absolutely make sure that this traffic is completely within the VPC and the SDDC, and there is no outbound or inbound directly with the SDDC from the internet. So we have this flexibility here. And I already have a VPC out from the SDDC towards the SDDC configured here. So for now, I will leave it as any because it's outbound. And I have to hit on publish for this rule to be active. Okay. So we are done with the NSX side of settings. So let's jump to the AWS side to configure the VPC security groups. And before we do that, let's check the ALV. Yeah, it is now active. And let's check the status of the target groups. Yeah, it looks like it's healthy. So I'll jump to the security groups and yeah, so I can see that. So I already have allowed HTTP access from the VPC segment, and we can also see a few public IPs. So I've just allowed HTTP access from my own machine. So I have not opened this to the entire world. But the key rule here is this one, the third entry, which allows access from the VPC towards the SDDC. So this is this might be confusing a bit because I've mentioned source as the VPC side, even though we are configuring this on the AWS side. If I go back to the diagram here, one might think that the source should be the SDDC IP and the destination is AWS. But since the ENIs are configured or using this security group, if I go back to the network interfaces page, under security group, you can see that these ENIs are using the default security group. And if I click on the default, it takes us to the same security group we just were seeing. Yeah. So if I look at the inbound rule, maybe I clicked the wrong security group. Yeah, so this is the default security group that is used by the linked VPC. So since the ENI is also using the same security group, we will have to specify the source as VPC, meaning we are basically allowing inbound access or traffic from this specific subnet, and this subnet is the VPC linked subnet. So we are allowing port 80 access from this subnet because load balancer is residing in this and onto the SDDC side. So this basically ensures that the load balancer can reach out to the web servers, and that's why the status is showing as active. If I can go to the load balancer or the target groups, it's showing healthy. So first let's access the load balancer. I will remove that entry and see how the behavior is. So to access the load balancer, we'll have to copy this URL and so we can see that we are hitting web server 2 for the first time. If I refresh, we can see that it alternates between web server 1 and 2. So these web pages are residing on these two servers here on the SDDC. So just a simple demonstration of round robin between the two web servers. So that's pretty much the setup of the load balancing. So let me quickly go to the security group and remove that entry and see what the behavior is. I've gone blind. So let me remove this entry, which provides access from the VPC towards the SDDC or towards the ENI.
And again, is that
So now,
change immediate, or is there any delay there that you have to be aware of?
yeah, this change is immediate, but there might be browser caching which might come into play. So we'll have a look at that. And let me go to the. Yeah, so this is from the caching basically, but if I hit refresh here, we can see that it takes some time, and we'll see the response how. So we can see that it's a 504 timeout. So basically we are able to hit the load balancer because I've allowed access from my machine towards the VPC. So this one. So this allows access to the load balancer itself, but the load balancer is not able to reach the web servers because we have just removed the entry from the security group. So I'll quickly add that back. In fact, if we look at the status of the target groups, so we can see that the status has changed to unhealthy. So, which means that the web servers are basically not reachable. Even though this monitoring happens at the service level, so even if there's connectivity and the service itself has any issues, it still turns unhealthy. So I'll add the entry back.
You just showed something there that was a good point actually. It's always a good practice to name when you create rules and entries like that, because as you saw there were already 4 or 5 in there, and the more you add, the harder it's going to be to trace stuff. So adding a description in is always a good idea to do.
Yeah, definitely, especially after some time it just grows and
Yeah,
might be difficult to manage. So yeah, let's see if this changes. Yeah, so we are again back up and we are load balancing properly.
brilliant. So are there any other gotchas or anything you've come across when doing this with customers? Any major flaws or really obvious things that are easily skipped, for example?
Yeah, so the custom routing table is one of the challenges we have seen because customers typically use multiple routing tables. So we recommend to use the default routing table, at least for the cross ENI connection. So that is one. And yeah, the security groups could be the other one, especially the challenge I just mentioned. So we might be specifying the source as the SDDC IP, but yeah, it's really the source from the VPC side. Or to keep this simple, we can also do this. We can point the security group to itself. What I mean by that is I can just copy this security group ID, and instead of specifying the subnet here, I can choose the security group itself and save roles. So what this does is it basically allows access to all the interfaces that are attached to this security group, and it provides access on this port, meaning any instance that is attached to the security group can reach out to another instance within the same security group over port 80. So we are basically opening the access for all the instances within the same security group. So this is an easier way to achieve the same objective. So if I go back and so we still have access. So this might be an easier way to provide that. But of course, customers can restrict access to specific subnet rather than the entire security group. So that's something to keep in mind. And this might be helpful if we have multiple security groups and we have instances attached to a different security group. So you can potentially add the other security group here so that it has access to the default one. So I think these are the two main considerations to achieve this. Or I guess these are the two main configurations where customers frequently hit issues.
Cool, thanks Prasanna. So we've actually had a question come in via the Twitch chat. It's from GreyFox01. I'm presuming there's lots of Grey Foxes then. So GreyFox01 asked us what we're actually working on, and he added some emojis for us. Thank you. So what we're working on right now, GreyFox01, is configuring a load balancer natively in AWS, which then load balances a pair of web servers running in our SDDC in VMware Cloud on AWS. You've missed most of, or actually all of the setup, but that's not a problem because we will post this video to YouTube as well, and it will allow you to configure your own load balancer natively in AWS. And then we also discuss some of the reasons why you might prefer to do this rather than running it as a load balancer within the SDDC. Okay, hope that was answering your question. Okay, so anything else, Prasanna, relating to the AWS load balancers this morning?
Yeah, I guess that's pretty much it. But just as a closing comment, so typically in a customer situation, let's assume that customer is bringing their own production web servers into the SDDC. So they typically might have FQDN registered with an ISP. So what they can potentially do is, let's go back to the load balancer. So they will have to configure a CNAME record towards this DNS name because their production website name might be different. So they will have to configure a CNAME record towards this name so that the requests are hitting this load balancer. So that's something to note in a production setup. And the second requirement is the secure certificates. So at the time of configuring the load balancer, we will have to import the certificates that are used by the production FQDN.
Yeah, good point.
So these are a couple of points to keep in mind.
Brilliant. Thank you very much, Prasanna. Rick, I don't know if you have any other questions or any points relating to the load balancer.
No, I was just, thinking about it, but to be honest, as always, PG, that was pretty straightforward. Thank you for that. And I don't really have any questions on top of my head at the moment.
Cool. Okay. So Prasanna, you can stop your desktop share now if you like. What I will do is I will just remind folks about our product roadmap and where we can find information. So we have a publicly available roadmap that everyone can find, and if you actually search by Spotlight features or available, you can filter on what's currently available now.
Will, I think I'm not able to see the screen yet.
Oh, apologies. Yeah, let me just
Oh,
share my screen.
I can see it on Twitch just fine. And also there was another question coming from Grey Fox. So yes, this will be, or this is actually being recorded, and it will be saved to YouTube later on, and you can just review it at any time if you like, once we're done with the session itself.
Yep, thank you, Rick. Right, so you should now be able to see my screen. Apologies for that.
Yep, working now.
Cool. So we have the publicly available roadmap. That's via cloud.vmware.com/vmc-aws/roadmap. And as I was saying, you can filter on spotlight features that have become available, and you can see when these were made available. So SRM connectivity checker. Actually, that's a really useful tool, actually, that I might just dig into very briefly in a second. So we can also check the release notes, and the release notes are available via the VMware docs, so docs.vmware.com, and then you can browse for VMware Cloud on AWS. And you just get a very brief update of new features released and by the date. So you can see there SDDC with external storage provided through a managed service provider. We got new regions, so Asia Pacific, Singapore, Canada, Central, and Europe. They're opened up in March. So always worth sort of bookmarking this page and going back on a monthly basis to see what's changed, what's been made available. And what I will also do is I'll log into our portal, and I will just show you the connectivity checker. This is a really useful tool that actually has a wider scope than just checking connectivity for the two main objects. So the connectivity checker has two bulleted features, so connectivity checker for HCX and connectivity checker for SRM, but actually, as it's running a standard set of tools in the background, you can use it for any other things you might be having problems with in your environment. So you can use it to ping various servers. We had one with a customer the other day that was having trouble with their hybrid link mode, so they were checking which objects were available, and if you're not sure where to see that, it's within the cloud portal, and we will just, once that launches, my system's running a little bit slow this morning, so we can go into our lab that we were looking at, and we can go into our troubleshooting tab, and we have hybrid link mode or site recovery connectivity use case, and you can run all tests, or you can literally pick one of the tests, and it doesn't matter which one you set this for, whether it's site recovery or hybrid link mode. Hybrid link mode obviously changes the options you have there, but you could run HLM, and you can run connectivity to your on-prem vCenter, so you could stick your FQDN in there. com.com, and then you could run the group tests against it. So even though you're not checking for hybrid link mode, it'd be useful to be able to check connectivity from your SDDC back to your on-prem vCenter. So yeah, just a really great little tool that has functionality wider than what it was originally designed for, something I know myself and a few of my colleagues use fairly frequently. I guess you guys, Rick and Prasanna, have used this yourself a number of times as well, yeah?
Yep, pretty handy
Yeah,
tool.
so this is one of the question frequently comes up, like how do I test connectivity from or to the management components? So quickly, Will, why can't we use an SSH session to one of the management components? Is that not allowed? Or? Yeah, so that's also another question that frequently comes up, right? So we don't provide SSH access to the management components, and
absolutely. So
yeah,
so obviously this is a managed service from VMware. So what we have to do is we have to restrict access to a number of objects to ensure that they stay in the state that we can manage them in, the state they were deployed in, so we can update them and manage them for you. So that also comes down to rights as well. So for example, your on-premises vCenter, you might have full administrative access, and in your VMware Cloud on AWS, you'll have noticed you're using the Cloud Admin account, which has a subset of the administrator rights. What it doesn't allow you to do is do anything around host management, because these hosts are managed for you, and to ensure their state, we restrict access. So yeah, good point, Prasanna. Right, anything
Cool.
else from
Yeah.
anybody at all?
So yeah, just since PJ was showing it as well, but you mentioned all those links. So just to go back to Dustin's onboarding guide, because that one is really handy. So whenever you have any question coming up, just have a browse through the book. It lists pretty much everything from the very beginning to day 2 operations and stuff. So
I was just trying to find the guide as well.
it should be Dustin on GitHub.
Yeah. Oh well, I'll find it. That's
yeah,
all right.
no, that's fine. So we can just post it later on in the video description, but that is really, really handy as well. So yeah, Prasanna was showing it in the beginning as well.
Yeah, it's a good shout out there. Dustin's obviously one of our colleagues in the VMware Cloud on AWS customer success team, and as you can see, it's updated pretty frequently. Last time end of March, so very up to date. Has some really useful stuff in there. You could literally run through this from start to finish to set up your entire SDDC. Goes into details about what the SDDC is, some of these images like the ones Prasanna was showing earlier. So yeah, very, very useful guide. And we're all very grateful to Dustin.
Yeah, true.
Right, brilliant. Well, thank you very much, guys. So if anybody is watching this on YouTube or indeed on Twitch Live, you'll notice down the bottom of the screen we have a few Twitter accounts there. So we have Prasanna, who presented earlier at Prasantech, myself, Will Rodbard, and Rick_VMC is Rick Hoffmann. We also have a group Twitter feed, VMware Cloud on AWS, VMware Cloud AWS. And this will be posted, this video will be posted to the YouTube channel, which is VMware YouTube. So go search for us. You can also subscribe to this, so you will also get a weekly reminder when the EMEA session is running. And we also have sessions for the APJ and American time zones as well. So if one of those suits you better, if you want to dial in live rather than watching the recording, please hunt those down also. With that, if there are no further questions from Grey Fox or anyone else online, thank you very much, and we'll catch you in the next session.
Thanks
Cool. Thank
much,
you.
everyone. Bye now.